Welcome, Computer Science Principles. This is second half of 113. So modulus operator, that's that percentage sign right there. But it doesn't mean percentage in computer science. It has a special operator like plus, minus, divide, and times. So what kind of operator it is? Let me just show you what it does. So let's say you wanted to divide some numbers. And I said 10. And I said divided by 3. And what would that be? 3.333, right? Repeating. Another way to do 10 divided by 3 would be like 10 divided by 3, right? Like that. So another way might be long division. What if I did 10 and divided by 3? Well, what would this be? 3 goes into 10 3 times. 3 times 3 is 9. And then you have 1 left over. So sometimes say 3 remainder 1, right? So instead of doing decimals, I did remainders. Modulo is the remainder. So if I say 10 modulo 3, it equals 1. So it is just the remainder of what you're doing. All right? So just a remainder. So what does that look like when we are doing this? So in here, or what do I use the remainder for? So one use I can have for this is to tell if a number is even or odd. Because if you do an even number and you go modulo 2, an even number will come out as 0, and an odd number will always come out as 1. So this is one very useful use for this. So for example, in this code right here, we have this reset I starts at 0 and it counts up to 10. It says remainder is I modulo 2. We run this. This is basically going to rotate. So the numbers go 1, 2, 3, 4, 5, 6, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 is 0. 1 would be 1. But 2 has a modulo of 0 because it's even. And this would be 3 being 1 because it's odd. And 4 is even, so it's 0. And 5 is odd. And 6 is even. And so on. So it's a way to tell if a number is even or odd. So that's why they do I modulo 2. All right? So just remember, and what another way to say even or odd is it's a very good way to rotate between three things. Like, what if I just wanted to make this modulo 3 right here? What would happen? Well, it's going to go 0, 1, 2, 0, 1, 2, 0, 1, 2. So we're doing a pattern of numbers. And sometimes we might want to repeat a pattern like that, right? And not just keep counting the numbers up, but just repeat like this. And we might find some uses for. So it says replace the print statement above. I'm going to fix that because I just kind of replace the print statement above with the following lines of code before running. Predict if REM will be odd or even, and replace the underscores with the odd or even. So I'm going to do this. Look at this. The number is, come on. So they're saying, oh, replace this. Now, when you replace things here, notice this, we haven't even done if statements, but it's got to be indented. So this isn't a very good thing to do. It's supposed to be number. This should say the number is even. So what we can do, okay, I think that's a dumb activity. Skip 14. We haven't even done if statements. They're trying to make you say, oh, is the number even or odd? 0 is even, 1 is odd. All right? Don't do this. Is 0 even or odd? Well, 0 over 2 returns a remainder of 0, so it's even. We count 0 as even. I thought there was some debate whether 0 was even or odd. I don't remember what that was. We use remainders to help us figure out what time will be. So, for example, if it's 1 p.m., what will be 13 hours from now? The answer is 1 plus 13 modulo 12, which is 2. So you can use it. Yeah, you might use it in real life, right? If I said, oh, what time will it be like 12 hours from now? You know, if it's 1:49 right now, it's going to be 1:49 in 12 hours. But it'll just be like AM instead. But so we do modulo, we just don't call it module. So a version of the Power Flower program uses the Modulus Operator, or Modulus, or Modulo. I think Modulo is plural. Modulus Operator to alternate colors of the petals. So let's run play. Let's see what it does. I don't know what this does. I haven't even run this. Okay. And it did that super quick, and it rotated the colors of the petals. So we've seen that before in the last, We see last time was just purple orchid, or dark orchid last time. But notice what's happening different here. So petals, here's the while loop for the petals. When petals less than 18, blah, 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 we switch the color dark orchid. And then it says, remainder is petals modulo 2. So this says, hey, if in REM equals 0, rotate it blue. So what's happening is the numbers start at 0 and go up to 18, but they go 0, 1, 0, 1, 0, 1. This is where if I'm rotating between two numbers, I can say, hey, anytime the number is even, or the remainder after you modulo is 0, rotate it. So just like the 1, 0, 1, 2, or the 0, 1, 0, 1 rotates, I can use this to like alternate colors like this, right? So it's kind of a neat way to help alternate by doing this modulo thing, all right? All right, so that's cool. The program, Modulus Operator, is used to get the remainder of the petals divided by 2. So I know we haven't done if statements yet, and that's okay. I hate when they throw that in, right? So what this does is, if this is true, do everything in here. I hate when programs do this. Oh well. But trust me for now that just works. If this is true, do this. Oh, whatever. I was going to have commentary, but we have to keep going. Recreate the program and visual code to run to see if code to see the new flower. Okay. Oh, what did they want me to change it? Okay, well, I can. So, like I said last time, you don't have to run Visual Studio. You could just, if you want to pop this out into a separate tab, I kind of like doing that. It's going to take forever. I'm not going to wait for it. Sometimes it's nice so you don't have to do it in here. I will wait for it. Okay, so then you can hit run, because we're probably going to be editing this thing, I think. The run button, and there I go. Same thing. It happens really fast. Okay, change the double equals operator of the if statement to a single equal. What happens? Let's try this. What if I change this to a single? Let's see what it does. Oh, error. It doesn't like this. Remember, double equals is the conditional. Single equals is just to assign variables. That's a common mistake. So if you get an error message like this, it said the line, invalid syntax, and points right here. It's kind of a hint that, yeah, probably that. You can do different. So one of the things, if you want to play with different values, what would happen if I just put, instead of 2, if I put a 3 here? Like, pause and think about it. You know how it rotated every 2 times, like back, What happens if I put a 3 there? What do you think it does? Let's find out. So it changed to blue every 3rd one. So if I put a 4 here, it'll probably change to blue every 4th one. There we go. Except at like the very end where it runs out. That's kind of cool. What if I do a 1 here? What do you think modulo 1 ends up being? Going the other direction. Everything's blue. Anything modulo 1, if you divide by 1, you have no remainder. So, yeah. So everything it's always 0, so it switches to blue. There we go. So different ways you can mess with those numbers and make some stuff happen. Okay, Tower of Modulus. As you have seen, a common use for the modulus operator is to determine odd or even numbers. Also be used to determine other conditions such as portions of a repeating number. For example, assume an architect hired you to design a tall tower and wants every 3 floors to alternate in color. As shown in the tower sketch to the right, floors 0, 1, and 2 are gray. What? Floors 3, 4, and 5 are blue. That's how that works? Okay. Confession. When I first saw this, I didn't realize there's 3 floors right here. This looks like 1 floor to me, right? Am I right, guys? Like, I didn't see. That's a very bad drawing. I couldn't tell there's 3 floors. 0, 1, 2 are gray, 3, 4, 5 are blue, 6, 7, 8 are gray, and so on. Can you think of how a modulus operator would be programmed to sketch this design? I thought it was just gray, blue, gray, blue, gray, blue. Okay. Program below draws a tower using one color for each floor, while a floor is a line drawn by the turtle. Create the program. Oh, so each one's a line. Okay. So let's see what it does. Okay, it's drawing lines, but that's so hard to tell. Okay, so walking through this, number of floors sets to 63, and then you start at floor 0, okay? Oh, they're setting some variables trying to make this fancy. Pen size is 5. That's really fast. What's going on here? Okay, puts the pen up, goes to this XY position. It goes to XY, and then sets it to gray, then does the next floor, and floor plus 1. Oh, it changes, so it adds 5 to every floor, so it goes up by 5 every time, and then changes it to the next floor, pens down, and draws the line for 50. Okay, I don't think you need to know all that. But what does it say? Okay, so what I want to do this, I want to do create the code so that instead of drawing the tower in gray, it alternates every 3 floors. How do I alternate it every 3 floors? So, okay, if you're thinking 3, it's probably going to be a modulo thing, right? So we're going to make this. After gray, instead of choosing gray, we're going to say, oh, I don't really like this. Well, I can do a lot of, how would you do this? So you might, I can do this, but let's just check the answer. Floor modulo 6 if the remainder of the floor is 2. Let's just put that in. See what this does. Where do they even put this in? I don't like how they copy code like that. But, okay. See what it does. Okay. So, it adds 1 to the floor. It says floor modulo 6. So, and it said, hey, if that number, oh, I see what they did. So, basically you have a group of 3, then a group of 3, and then it rotates. Basically every 6 we have a new rotation. So what they did is they said, hey, modulo 6 this, and then you have 6 options the number could be. 0, 1, and 2, or 3, 4, 5. So they're saying, hey, if it's bigger than 2, so 3, 4, 5, make it blue. Otherwise, if it's less than that, keep it as gray. Okay. That's one way to do it. You just paint that in there. That's kind of weird. You kind of jumped ahead really quick. The architect thought your design was great, but discovered the tower is too tall for the site they want to build on. Each building must have no taller than 21 floors. You propose making 3 smaller towers, still alternating colors, even between buildings. The end result will be similar to a checkerboard. Okay. Even between buildings. Okay, a checkerboard. Okay, I kind of get this. You can modify your while loop. So what they're kind of looking at, I'm going to just sketch it on here. I guess you would, so you do kind of these buildings. Might have like 3 buildings like this. But then, and then you might have like floors, right? Like this. I'm going to do a bad job right now. And like, so if you're drawing, like that's red, this is red, this is red, then this would be red, and this would be red. So you kind of alternate like this, like a checkerboard. Okay, I can do that. Okay. So, end result will be similar, so we're making a checkerboard. You can modify your while loop to create 3 separate towers, still alternating colors, every 3 rows. And then the architecture throughout your sketches want to add even more. Okay, so let's do this. Okay, I'm gonna have fun with this. What's this? I have to tell what? It thinks I'm a robot? I want to log in. Man, so many weird computer problems today. Okay, so all paste. Let's go. I'm gonna run this again. Now, one thing to notice, the first 2 rows are gray, and I really want the first 3. And I think the problem is I need to put this not here. I need to put it right here. I need to put it before the floor gets changed. I think this will do it. Yep. Okay. So if you're confused why this not, I just want to make it that way. And so it works. All right. So now, what do I want to do? Oh, I want to do multiple. Okay, I want to do 2 towers next to it. So, first of all, how do I make a second tower? Oh, man, actually, how am I going to do this? Oh, we could just do one right next to it. So, we can modify my while loop to create 3 separate towers, still alternating colors every 3 rows. There's actually a few different ways you can do this. So, you can modify this loop. So, one way is you can just do 3 towers at a time, right next to each other, like 3 towers at once. We could do it that way. That's kind of how I would do this. I would say, hey, if you want me to do this 3 times, let's just copy this while loop. Let's do it again. Like, what if we did this twice? What would happen? I don't know. And then it's going to keep doing it, I think. Okay, it just does it on top. But let's say I wanted to shift this one over. Oh, you have to reset floor again. So, and then I have to, number of floors can stay. And then one thing is like, I have to shift the next building over. So I'm going to move that X. X, oops. See how the X starts at negative 150? So this is one way I could do it. X equals X plus 50. See what happens. I don't know if that's right. This might give me something. Oh, it shifted, but then I got to shift it back down. I'm going to shift the Y back down to Y equals negative 150. Shift it back down to Earth. So let's see what happens. I'm going to show different ways of doing this too. So there, I have 2 buildings, right? But I need to have this 3 times, so I will just copy this a 3rd time. Let's see what happens. Okay. Now I want to alternate these like checkers. So how could I do this? Well, I can just flip these colors. Do they spell it gray with E or A? Sometimes it's spelled with E. They're both are correct spelling. So let's just flip those. I mean, that does it. There I go. I think I should have shifted over more than 50. Maybe, but oh well. You want to shift over more than 50, that's fine. But there you go. We did it. Now, we could have done this different ways. I think add a new modulus calculation and an if statement to start a new building in a new location after 21 floors have been drawn in a building. Okay, so 21 floors, but we're doing 63 floors. Oh, no taller than 21. Okay, so here's what they wanted. Remember they said no taller than 21? So we're splitting this up. Okay. Here's what it's really supposed to look like. Sure. And I could spread those out farther if I wanted to. I thought it was only 50 because this said you move forward 50. There's like some there's like bleed over a little bit because of the length of the pen. Okay, so let's say, so this worked, but I think what they wanted you to do was not do it this way. You can actually do it within, you can do it within the while loop without just copying and pasting more while loops. Add a new modulus calculation, an if statement. So, oh, you can keep this. I don't like that. I wouldn't do it a different way. You said 63 still, but I don't want 3. So, hey, I have one version of the code that works. I'm going to delete this. Let's try to do it their way. So, they want this to be 63, but they want to say like, hey, every time you have, every time you get too big, I want you to move over. Okay, so every time it wants you to, oh, so here's how you do this. Every time after your 21st floor, I want you to start a new building. That's what we're going to do. So here's how we do this. And we're going to say, I think we can do it right. We'll do it right here. So we're going to call this building. We'll call it new building equals floor modulo 21. Watch this. Every 21 floors, I want you to move over. So what we're going to do, if if new building is equal to, it's going to start at 0. Oh, you just say 0. This will work. It's lazy, but that's fine. I want to shift the x values over. Oh. X equals x plus 50. What if I just had that? I wonder what happens. I don't think that solves it. I wonder what that does. Yep. So I kind of did this, but I shift over at the start too much. So I'm going to say if it equals, 20. So 0 through, no. I wanted to do the first 20. So how would I do this? I mean, there's ways I can hack this. I don't want to. I want to do this right. We could say if it equals 21, it'll never equal 21. What if I say if it equals 20? I don't think that's right either. Oh, that is right. The 20th one's shift over. Okay, but now I need to shift down as well. And I'm going to say y equals back to the bottom. Oh, that was it. Sick. It's okay. I did it a different way. Putting those lines in. Awesome. So what I did is said, hey, after, so it paints, it says go to here, switches the colors. Doesn't paint till here. So after it does this 0 through 19 times, then it will shift over and start at the bottom again. Huh. Oh, I learned something today. That works. 0 through 19 does it, right? I thought that would only do 20. Huh. I'm surprised that works. I didn't expect it to. But all right. I'm good at this. Up till now, you've written algorithms and solved problems that are considered decidable when they produce some predictable or correct output. However, some are computational problems that are undecidable. Add to your notebook a decidable problem. Okay, so you can decide, is a problem even? What's an undecidable problem? It's one in which no algorithm can be constructed that always capable of providing a correct yes or no answer. Oh. What's a problem? You can always tell if it's the number even. If I give you a number, is it even? Okay, so let's do an undecidable problem. So an algorithm can be constructed that is always capable of providing a correct yes or no answer. I can't think of a serious answer, so I mean, here's one that's always correct. Should I go to John Smith's subs? But that's undecidable. But that's always yes. That's not what they're looking for. I'm not sure what they're looking for there. That's kind of a weird question. Next one. Examine this program. Suppose a user enters a number that's greater than 0. Will the program ever stop running? Oh, so this is what they're kind of going at. So let's say you enter a number and you enter 5 or 6. And it says, while 6 is greater than 0, add 1 to 6. So what they're trying to say is this is undecidable. And this is one of the dangers you have. You have what's called an infinite loop right now. This is stuck because I is always getting bigger, so it'll always be true forever. So it's never going to leave this while loop. This will just run forever. You don't want to do that. So what if I did like -5? It'll terminate right away. So this is one of those traps where if you do a number too big, it's not going to work. So I'll show you. And like this doesn't even do a good job of showing that off. What do you go? Print I. Watch this. Now this will show off what's going on. Oh, you can't do that. Print. My bad. You have to do it this way. I forgot. Watch this. Watch what happens. Enter a number, 9. It just keeps going forever. And this shows this off way better than that did. It's just going to keep growing. And it's going to keep looping. Because it's always going to be greater than 0. Until maybe it stops at some point. So this would be like those undecidable problems. That's what they're getting at. Let's see. The algorithm above demonstrates a classic example of an undecidable problem, referred to as Turing's halting problem. Given an unknown input, the program is not guaranteed to terminate or halt. So that's undecidable. It's like if you're going to John Smith's subs and you're like, do I want the steak bomb or do I want the turkey sandwich? And like, you don't know. You can't decide because they're both good, but you can only choose one. That'd be a great example. That's what we're looking for. That's it, folks. To your conclusion questions, I'm out of here.